Hello everyone. This is section 2 about Aspen HYSYS software. And now I'm going to teaching all of you. Mm, in order to conduct process studies and predict behavior of the process simulation by software is necessary. Also, economic studies should be considered. In a simulation of process, the aim is to check input feed, type of process, design of equipment process, the output of each unit, and the overall products of refinery or unit. The most important factor in a process is quality and quantity of product. The process behavior of equipment is important. In order to produce a quality product, appropriate level in all process. In process, choose the type of thermodynamic model is really important. The choice of thermodynamic model depends on type of fluid which aims to predict and calculate thermodynamic properties. In addition, process properties, thermodynamic behavior of a process also shows phase of a process, which is the basis for its diagnosis with software. HYSYS program is menu bar, which means we can access new information by click on everything. Thermodynamic model means choose an equation of state. Thermodynamic model predict process behavior, phase changes, thermodynamic properties, and physical properties. In terms of thermodynamic, the thermodynamic model controls calculation. The presence of hydrocarbon amine components along with electrolytic system for process has a predict effect on package selection. The choice of thermodynamic model depends on behavior of process and determines calculation on behalf of the software, as well as is compatibly with natural reality. This calculation should be chosen in such a way that program answers and includes the facts. Each of thermodynamic models provide us with a calculation or give formulas based on which behavior of process is calculated. Thermodynamic properties are calculated according to the formula activation energy of all relationships, and heat transfer coefficients are calculated according to the formulas, and thermodynamic equations shows behavior which includes thermodynamic calculation and the fluid properties and behavior. And today I want a simulation a compressor. Previous video I talked about compressor device and the other devices. Increase of pressure of liquids and density of gases in industry is very important. For this reason, many machines were invented to work with dense gas of fluid pressure. This is my example. I want to add this I want to add these components, for example, methane, ethane, propane, until hydrogen. And these are uh, these are percentage composition. I consider mole fraction as the basis of calculation. Mole fraction means it expresses the number of moles of a specific substance in total number of moles of a mixture or solution. Thermodynamic model I consider for this example is Penn-Robinson. Almost we can use Penn-Robinson model for most of compositions. In fact, the system works, but basically this thermodynamic model used for hydrocarbon fluids. And for this model, temperature is 41, 41. The temperature is 41.29 degrees Celsius, and pressure for compressor is 1423 kilopascal. Mean the molar flow is 9135 kilomole per hour, and the duty for a compressor is 5,000 7,557.32 kilowatts. And this is my example. And now I am going to open Aspen HYSYS software. Okay, at first I click on Start menu, then search, name the program. For example, I write Aspen, yes, Aspen HYSYS, then click on and close the window. Yes, this is Aspen HYSYS software. And now I'm going to open new page. Click on new. Yes. And now I'm going to add components. These are my components. Yes. All right. Add components. I am going to add methane, ethane, propane, ibutan, N-butan, ipentan, N-pentan, N-hexan, hexan, N-heptan, N-octan, N-nonan, and I have water in the hydrogen components for this example. And now I'm going to write water, water, yes, hydrogen, yes. I add all components. After that, we add a thermodynamic model. Yes, click on add, and I'm going to choose Peng Robinson because we have hydrogen components. Yes, I added, and I want to say something. If we don't choose thermodynamic model, we wouldn't enter a simulation environment. On the other hand, when I choose a thermodynamic model correctly, the fluid package changes. Yes, the fluid package changes from red to blue. After this step, we enter a simulation environment. Yes, I choose, yes, I choose SI unit for this example. And I choose material string. Click on it and choose a name for system. I think fit, yes, fit is great. And the other, uh, yes. And now uh, I enter temperature 40, 41, point 29 degrees Celsius. And for pressure, yes, pressure, molar flow, pressure is 1423 kilopascal. The molar flow is 9,135 kilomole per hour. The we can we can see unknown composition. This message tell us we should enter the present of composition for run flow. Click on composition and click on edit tab and choose mm, yes um, I consider a mole fraction for basis calculation and enter the percentage. Yes, automatically, automatically, the system normalize percentage and adds them to the number of 1. Yes, click on OK. Now system is run and yellow color change to green. I close this window because finish. Yes. And then now I'm going to choose a compressor. Yes, it is a compressor. And now I click on it and choose a name for compressor. I choose comp. Yes. Only one flow is entered compressor. Its name is feed. Then I choose it for inlet. Yes. Next, I need to define and the energy flow and outlet flow for compressor. So I define energy flow and I'm going to call capital Q. I define outlet flow for compressor. Mm, its name is yes. Its name is yes. Exit is suitable. Yes. As you know, can see a compressor didn't run. So we can see unknown duty message and we should enter number of duty. And now click on parameter tab and I'm going to enter the number of duty. This is the number of duty compressor. Thirty 2 kilowatt. Oh yes. Yes. Now compressor is run. And close the window. And now I wanna say something. Please pay attention to me. Yes. I going to right click. Yes. I'm going to right click and choose show table. We can see uh, temperature, pressure, and molar flow for feeder stream without click on directly. And now uh, I right click. I'm going to right click and choose change icon for compressor. Yes, We can choose one of them. For example, yes, this is one of them, and I think it isn't really beautiful. And I am going to right click, choose uh, change icon, and choose one of them. Yes, I think it is better than the other. I change, I change it. Totally or normally, if we want to see temperature, pressure, or the other, for material stream, or for energy stream, or the other devices, we can right click and choose show table, and after that we can see temperature, pressure, molar flow, and the other item for feed stream, for material stream, and the other. And now I want save this file. All right. Mm, at first, I click on file, then choose save as. I want save my file on desktop. I write a name for my example. For example, comp, yes, comp R1, and choose and or click on save. Okay, this is my example. I save it. And today's example is over. I hope you're successful. Bye.